Okay, Peter, is this your favorite video?
You know, I must admit my brain is totally conflummosed by this lot. It always has been. And I personally believe, and I'll cut this short, that we live in what we consider reality, and that's the only way we can live. And this theoretical stuff is fine. It's very, very interesting, I must say. It's very challenging. But it is purely scientific theory, which cannot affect our everyday lives unless you're into astronomy and trying to work out what happened to stars and when they exploded and that sort of thing.
Yeah, for me, it's simple enough. I think you used a couple of times, you used the description, time is an illusion, which is just what I believe. But maybe I'm made up of photons, not anything else, because I just believe like a photon, time doesn't exist for a photon. So maybe I don't have mass like a photon. I don't believe time exists. But the problem is, time, if you measure time, measuring time, a clock speed is affected by gravity and also by the speed it's traveling at. So if you've got two clocks, you got them both on at the airport, in one in your left hand, one in your right hand. You give one to a guy that's getting on an airplane, and he goes at faster than the speed of sound a few times around the earth, whatever. It comes back. That clock will have it display a different time to the one that you've got in your other hand. Same thing with gravity. I think as gravity increases, time slows down. Yeah. So how does that work? That is, it's not just time that's slowing down. It's the actual instrument measuring it that shows a different time. How does that happen?
The measuring is the problem, definitely, I agree. But as they did point out, the arrow of time is very real, and you can't change the actual order of events.
Yeah.
The way that they happen and the way we perceive them is a different matter.
Yeah, to me, that's a science fiction concept of going back and changing time, and it's all science fiction because time doesn't exist, although it does. Okay.
It's a dimension, and there's no way you can. And
No,
his title here.
That's one thing I
when actually
disagree on.
were you?
The one thing I
When
disagree on
actually
is that
were
time
you?
is a dimension. It's not a dimension. It doesn't fit the
It has to be.
qualification of requirement for a dimension.
It's no good saying, I will meet you for a cup of coffee at Whale Coast Mall on Tuesday. Or not even on Tuesday, I'll meet you. So I've defined the position, the actual position where I will meet you. But I have not defined the time. So you're going to say, well, what time? When? What day?
Yes, but what does that time that you're using, what does it mean, really? It means, the fraction that the Earth has spun on its axis, if it's a part of a day or an hour or part of a minute, whatever. I mean, why does a minute have to be 60 seconds? Why does an hour have to be, it's just arbitrary. Chosen.
Yeah, that's pure measurement. Measurement is a human construct.
It's just a human construct, yeah. So what it means, I'll meet you at the mall in 3 days' time, which is after the Earth has spun around 3 times. That's all it is. It's something which has physically happened, which you then detect. Okay, that's now happened. That's when I should be there. After that has happened. So you time your motion to coincide with when you need to be there after that has happened. You don't have to call it time. It's relative motion. As Einstein said, you cannot separate space and time. They're one thing. It's space-time. It's not space and it's not time. It's space-time.
Derek, just 2 comments.
Yeah.
If I say we are going to meet with Peter at 10 o'clock at Burgundy's,
Yeah.
I've defined the place and I've defined the time. And time in that instance means that the watch on your arm and the watch on my arm and the watch on Peter's arm will all three show 10 o'clock. And then we'll be meeting there.
And you got to
The
hope that
second-
one of us didn't travel on the ISS around Earth a few times in the meantime, because then your watch would be wrong.
It's not a hope, it's a certainty. The second comment is the best sort of within our understanding absolute time is sidereal time. The time, sidereal years, the time elapsed between what the stars look like now and what they will look like in about 365 days later. And then in how many intervals you divide, you can decide what you want to. The old Babylonians gave us the hexadecimal system of 60, 60, 60 and 360 degrees, etc. But that you could use any other system that you want, but that's a man-made construct. And Peter's comments about you can't, well, causality cannot be changed. In other words, the sequence in which events happen cannot be reversed. But time being something physical, a dimension or whatever, you can't do that. It is, we don't fully understand it, but space-time is the universe in which we are living. And any attempt to separate them you're going back to classical Newtonian physics.
Yeah, I just love Newtonian physics because I don't travel at the speed of light. So relativity doesn't really affect me.
Well, they still use Newtonian time to plan space missions, even distant ones.
Yeah. So it's all.
Annelies had an interesting comment on the email. Annelies, can we hear from you?
Yes, good evening. Now, I was asking about telomeres. You know, those are from your DNA, so it would actually start losing the length eventually, according to your age. And how would that know when is the time to die? Because it reaches a critical length and then everything stops. So I think that was also related to the question of time. How is that then codified? Thanks for an interesting presentation or a video.
I think telomere is literally a fixed chemical reaction almost. It takes time for that telomere, whatever, to break down, and that determines the death of the cells or whatever. And it's just an exact. It's got nothing to do with a theoretical or abstract time or anything. It's just a rate of chemicals change, which happens at a specific rate, and it's different. That's why dogs live a different age to humans, to parrots, to turtles, whatever.
I think that also reminds one of the decay rates then of nuclear. Can I say, yeah? Because there also you have something consistent. In fact, time is measured exactly by using a nuclear clock to standardize it.
A nuclear clock will measure time differently in a different gravitational field or a different velocity, relative velocity. So that's what's so mind-boggling about time. Relativity affects it, whatever is measuring it. And the mechanics of that is a total mystery to me. I see we've got a couple of comments on chat. Just let me have a look at those quickly. Jenny says, fascinating, thought-provoking, thanks. Peter Kochel says he agrees with Peter on that that time is a physical dimension. I'll try to explain my view of that simply because if you consider a physical dimension, like you have three axes in different directions, so the definition to me, making one of those, the x dimension, say different to the y dimension or z dimension, they're all at 90 degrees to each other. So if you have a particle moving along the dimension, it is not affecting any of the other dimensions. It's moving only along the x direction. Same,
Yeah.
you cannot define time like that.
Sorry, Derek. What I was getting at, I suppose, is if I think of measuring a distance outside in my garden, if I can measure it width, length, and height. But if I compare with the other side of the world in England, my notion of up, down, left, and right is totally different.
Yes.
You know, it is a spatial measurement, and I can measure that space using a ruler. And I
Yes.
can do the same thing with time. I can measure a time interval using a clock. So in that sense, I'm saying it's physical. It's not something I can hold in my hand, just as I would argue 2 points in space I can't hold in my hand either. But they are. It's a physical thing. That's a point I was trying to make.
Yeah, look, it is a measurement, but the statement that there are 4 dimensions, 3 of space and 1 of time, I just don't agree with that, because you cannot, because you can alter things in the x dimension without altering them in the y or z dimension. But you cannot alter things in the time dimension without altering them in the other dimensions. And therefore, it is not an independent dimension. It is, as Einstein said, it is absolutely part of space. It cannot be separated. Therefore, I don't regard it as a dimension, except that it is a measurement in a sense.
Well, if I Pierre's probably the person really to explain this, but if I think of something in orbit around the Earth, it completes one orbit and it returns to exactly the same position in space, but not in time. So therefore, it has moved in time, but not in position. But you know, there is an acceleration involved in that.
Yeah. Well, but in the meantime, that whole system has moved around the sun.
Oh, that's correct.
So relative to something else, it hasn't completed an orbit. And in fact, if you take the rotation of the Earth and its rotation around the sun, we think the Earth has rotated one day, but it actually has rotated more, because at the same time it's been rotating around the sun. So Pierre, what is that? What are those differences called again? Can you just?
Sidereal.
Well, sidereal
one-
time is the sort of,
Sidereal.
but I just want to comment on Peter's very good, or Peter Kay's very good explanation.
Yes.
I just want to extrapolate the 3 spatial dimensions you can individually measure.
Yes.
Okay. And you can measure the time interval between 2 events.
Yes.
By that argument, all 3 spatial dimensions and time are dimensions and physical. My interpretation of time is just the interval elapsed between 2 events.
The other thing as well, furthermore, is you said that gravity affects time, but it also affects distance as well, measurement. So
Yes, it does.
in that sense, time and spatial measurements can be treated exactly the same way by gravity.
But when you're talking of accurate time measurement, you're talking of a clock attached to yourself, your own clock. Any other clock that moves relative to it will give you a different time. So if you're trying to define an absolute time, it does give you a number of wavelengths or intervals or frequency of a cesium atom at a certain space and kept there. I think it's in Paris somewhere.
That's right.
So,
Right.
but it's localized at one place, and we define everything relative to that on Earth.
Yeah, look, I just think, the way that you measure, the most of the ways of measuring time, what you're actually doing is you're measuring a relative change in one thing relative to a relative change in something else. That's what you're actually doing. So it's a perception, and that perception changes depending on your frame of reference. So it is. I think what this video was trying to get at is that time is actually just a human perception, a human
measurement.
illusion which you require to make sense and live in the world.
Can I just make quite an appreciative comment? I think the illustrations used in this video are excellent. The guy who designed this bloody will deserve some other prize.
Yeah, it's brilliant. The series is really brilliant.
Guy referring to both genders.
Anyway, yeah, when you're getting to the age, well, I'm younger than most of you, but then you prefer to imagine that there isn't such a thing as time.
I was going to say, Derek, that
time
shows
seems to
time
be
does
speeding
exist,
up.
eh?
Time is your enemy.
I tell you what, time is very, very important at the present moment because it really feels like a glass of wine.
Yeah, good point. Good point. All right. Anybody else like to give us the?
I just want to say that's a new dimension which Peter has defined.
Yeah, the wine dimension, fifth dimension.
Yeah.
All right. I don't think we really disagree on anything. I think there's some mystery to it. There's some things which just will always be mind-boggling about it. And I understand that gravity affects time, but I'll never understand how or why. I know it's all to do with relativity and general relativity, but how it works, in fact, how gravity works is also a mystery to me.
Its potential and kinetic, total energy is constant. If you've got more potential energy and a stronger gravity well, there's less kinetic energy or movement energy, so it's going to affect the wavelength of the light. It's actually quite simple.
It's simple, but it's complex.
Yeah.
Okay, great. I've had supper beforehand. I don't know if some of you want to still go and have supper. Have we got anything more to add?
No, just to say thank you. It's very interesting.
All right. Thanks.
Yeah, great video.
And we will record this discussion. So when somebody said something idiotic like I sometimes say, then you can point it out afterwards and there's the proof. Okay, thanks for your attendance and we'll see you next time.
Thanks, Derek. Excellent video.
Cheers, everybody.
And
All right.
Bye.